Hi geometry students. This video is on medians and altitudes in triangles. So we're not dealing with this overlapping triangle thing right now. We're going to talk about that in class, but for these videos, just medians and altitudes, and we're just going to introduce some vocabulary about what a median and an altitude is in a triangle, and then that's going to allow us to kind of use those definitions as we continue to do proofs involving triangles. So we say a median is a segment that connects a vertex of a triangle to the midpoint of the opposite side. So there are actually three medians in any triangle. So if we look at this first diagram, triangle ABC, the median that's drawn here is connecting vertex A to point D, and point D is the midpoint of the side opposite vertex A. So we see that when we draw that median, it's splitting side BC into two congruent parts. And that's going to become useful when we're doing proofs, because now we know like we have two segments that are equal. Similarly, we could also draw a median from like vertex B to the opposite side AC, or from vertex C to the opposite side AB. Here is just another example with two medians drawn in. So how many medians does a triangle have? It will always have three, because there are three vertices. I can draw a median from any vertex to the opposite side. Okay, we're going to come back to that in a minute, but now let's think about altitude. An altitude is also known as the height of a triangle. We've talked a little bit about altitudes when we were talking about special right triangles, but it is a segment from a vertex of a triangle that is perpendicular to the line that contains the opposite side. And this idea of like to the line that contains the opposite side is that sometimes your altitude lies not on the opposite side, but outside of that triangle. So we're going to look at some examples. I'm going to kind of number these or letter these A, B, and C. So we kind of think about. So we have like three distinct examples. In example A, I have two altitudes drawn in here. So like there's an altitude from vertex A, and if I'm trying to draw a perpendicular line to somewhere on this side, then it looks like it's right around there. Same thing for BE is that altitude from vertex B to the opposite side. And then there could also be one that I could draw in that goes from C to the opposite side, and it looks like it would look something like that. Okay, but there are some kind of special situations, and that's what we're going to write in on these notes about altitudes. So one special situation is that an altitude could actually be a side of a triangle if we have a right triangle. And that's what's happening in B. Okay, so in B, well, if I start at vertex C, I have this altitude going down to point D, right? So that one is actually not a side of the overall triangle. But if I start at vertex A, and I want to go to the opposite side here, then the segment that would be perpendicular to that side is exactly CA, right? That segment connects vertex A to the opposite side at a right angle. So, and it's the same is true for if I start at B and I want to go to the opposite side, I would go along, I'm going to use a different color. I would say B, I would go along here, and that would connect to my opposite side, CA. Okay? So if I want to kind of just write that down, I could say CA and CB are altitudes in diagram B. So the idea of diagram B, just so we're clear, is right there. Okay? They are also sides of the triangle. The next example, it might be a little bit harder to visualize, is we could also have an altitude lie outside of the triangle. And this is getting at the idea that the perpendicular line could be on the line that contains the opposite side, but not necessarily on the opposite side. So in this example, it's kind of hard to like visualize. This looks like a lot is going on, but if I'm thinking about the triangle ABC, so it's the triangle I'm starting with. I'm going to outline in purple. Is right there. Well, starting at vertex A, if I want to draw the altitude, it connects to point D. That's how I form that perpendicular. But if I start at point B and I want to form a right angle with side AC, nowhere between point A and point C can I connect from point B to over here that will form a right angle. The right angle happens when I go this way, right? So now I see point E is kind of on if we kind of imagine extending side AC forever, point E allows me to create the altitude BE, which is outside of the triangle ABC. So we would say BE is an altitude in diagram C. And by diagram C, we're looking here. Okay? There's a similar altitude to draw if I consider starting at point C and going to the opposite side, BA. So we'll check in about this in class, but can you draw the altitude that goes from point C to the line that contains BA? Where might that fall? And we'll talk about that in class. Okay, so you can pause the video here to draw that in, and I'm going to keep going, so you can press play when you're ready to keep going. The last thing I want to talk about is this is just a preview of what we'll be doing later. Later in the year, you're going to use the altitude or the height of a triangle to find the triangle's area. And you might remember this from middle school, but the area of a triangle is 1/2 the base times the height. Well, that height here is the same idea as the altitude. Okay, so again, we're going to be talking about all of these ideas in class, but what I'd like you to do next is, before you come to class, just go through these 4 diagrams, and you want to decide for each of them, is the segment AD, they all have a segment AD, is it a median, an altitude, neither, or both? Okay, and we will discuss those answers next time in class.